A new chapter, chapter 4, section 1, we're talking about triangles and angles, because by the end of class, these are our goals. You should be able to classify the triangles by their sides and their angles. So classify the triangles by their sides and their angles. So each triangle is going to have 2 names. How many names, guys? 2. And then also the second goal is, no matter what kind of triangle I put in front of you, if I give you some information, hopefully you can finish the other angles inside the triangle. We'll go through this. Okay, let's start with our vocab. Guys, we can draw one huge picture. Triangle, raise your hand. Got it. I know what a triangle is. We don't really need to write a word definition, right? But let's talk about vertex and adjacent sides. I think for this one, let's draw a right triangle. So I'm going to draw it nice and huge. Do my best. Guys, on there I have to have something else if it's a right triangle. What do I have to have? The box, right? So put in your little boxy box. I'd say that's 90 degrees. And then let's name the vertices. Do you know what I'm talking about when I say vertices? Yeah. Oh, good job. Plural vertex. So let's call this top one point A, this one point B, and this one point C. Okay, so vertex, that's the point of a triangle, okay? Vertices, all of the vertexes, right? Plural for vertex. All right, adjacent sides. This can be confusing. Adjacent, we talked about. Seems like it was the first chapter. Adjacent, that vocab word stands for right next to, I think neighbors. Adjacent sides, I'll give you a pair. Adjacent sides would be side AB, segment AB, and segment BC. Okay, why are those adjacent? Check it. They've got to touch each other using the same vertex. So AB and BC, what's the vertex they share? B. They're both using B. Okay, but that's not the only one. Sure, AC and BC. So right here, here's AC. Here's BC. Guys, they're adjacent because they share what vertex? C, they're sharing C. Okay, I always have a hard time with the last. CAB? Is that what you said? All right, I'm going to sneak it in right here. AC and AB. Oh, yeah, because they both share A, right? Here's AC. Here's AB. They both share A. So those are adjacent. So if you have a question naming adjacent sides, make sure they're touching each other out of vertex. Okay, legs. Let's go to the next vocab word. Guys, legs only used for right triangle. Only in right triangles. Now legs, most of us, everybody in this class at least, we each have 2 legs, right? So in the right triangle, there's 2 legs. So, which ones are they? Right here, the legs have to be what's touching the right angle. So here's a leg, and here's a leg. So the legs in our picture right here would be AB and BC. Again, if you want to write yourself a little note, just put they have to be touching the 90 degrees. They have to share that vertex, the vertex at 90 degrees. Those would be the legs. There's always 2 of them. Well, what about that poor last guy? So what would AC, what's the vocab word for that? Anybody know? Yes, that's the hypotenuse. Okay, it's on the next page on the board. So the next one, the hypotenuse, is just AC. Okay, you have to remind yourself, the hypotenuse has nothing to do with the 90-degree angle. It never touches it. It's always straight across from the 90-degree angle. So again, hypotenuse never touches the 90-degree angle. It's always across from it. Okay, base. Base is usually in an isosceles triangle. Do you know what isosceles means though? Show me with your fingers. How many sides are congruent in a triangle that is isosceles? So it's 2. So 2 pieces are congruent. So we've got a triangle like this. We'd say this is congruent to that. This would be isosceles. Okay, I'm going to stretch you a little bit. Guys, if those 2 sides are equal, what's going to happen to this angle and this angle? Do you know? They're also going to be equal, so let's add that into our picture. So that's equal to that. It's always the case in isosceles triangles. Okay, but let's go back to our vocab word base. We're just trying to figure out the base. If this is A, this is B, and this is C, the base is always the one that's not one of the congruent sides. So it's not AB and it's not BC, so it would have to be AC. That's the base. Oh man, interior angles, exterior angles. Interior angles, guys, what does interior stand for? Sweet. What does exterior stand for? Okay. I think you can handle interior angles, but you're kind of scratching your head at exterior. How do we do that? Let's do one big triangle again. Okay, interior angles, I'm going to color them in blue. Here's an interior, interior, interior. Thumbs up, you okay with interior angles? Yeah? Okay, what about exterior? Exterior, I always take my pen or my pencil and I exaggerate the sides of the triangle. So right here, if I kept drawing on this red line, keep drawing, exaggerate. Just stretch it out just a tiny bit. So this one, keep going, exaggerate. This one, keep going, exaggerate it. Then there's your exterior angles. I'm going to color them in green. So we've got this one is an exterior, this one is an exterior, and this one is an exterior. Whew. Okay, why are we talking about exterior angles? We're just talking about triangles, but we are talking about their angles too. Guys, look at, I bet you can figure this out. What's going to happen with this blue angle and this green angle? Add them up, what are they going to equal? 180. They're a linear pair, they're supplementary. That might come in handy later on. Okay. All right, corollary, you know what? I'm going to erase what I colored over when I typed it in. Don't stress too much about this, but that's what a corollary is. Corollary to a theorem is a statement that can be proved easily using the theorem. So again, don't stress if you're like, Cora, what? Who cares? Because corollary is just something easily proved. It's like a step off of a theorem. So right here, we're classifying it by sides. So this triangle has this side congruent to this side, congruent to this side. So it has 3 congruent sides. Do you know what kind of triangle it is then? What's the vocab word? Perfect, equilateral. Can you spell it though? Equilateral. Okay, we already went over the next one. Guys, if it has 2 sides congruent, what kind of triangle is it? Okay, can you spell it? Isosceles. ISOSCELS. Isosceles. Okay, I'm going to stretch you a little bit. Guys, do you remember which 2 angles are going to be congruent on this isosceles one? Can you describe it, Abigail? Which ones? Yeah, one's on the right. This one will be congruent to that one. Maybe add that in your picture. That's kind of later on in the chapter, but we might as well get used to it. Okay, last one. This is one that Allie did on the warm-up. Guys, if no sides are congruent, what kind of triangle is it? Scalene. Nicely done.
Where do they come up with these names?
Yeah, I don't know. Okay, next one. We've got classification by angles. So if you're just looking at the interior angles, if it's got 3 acute angles, all of them are acute, kind of gives it away. What kind of triangle is it? Yep, acute triangle. Okay, next one. I'm kind of curious if you guys know this. What if you're just looking at the angles and all of them are congruent? Do you know the vocab word for that? Anybody? It's really close to equilateral, but equilateral is talking about sides. You ready for it? Equiangular. The angles are equal. So this is an equiangular triangle. Yeah. Okay, let's think about this. Guys, if all those angles are equal, do you know what every single one of them has to equal? Yeah, you got it. They each have to be 60. Add it to your picture. 60, 60, 60. Every single time. If it's equiangular, they are always 60 degrees. Okay. This next one, one right angle. Even if there's only one right angle, what's the triangle? What kind of triangle? Right triangle. Okay, and then last one, we've got 1 obtuse angle taken over. We've got 1 obtuse angle, it's yeah, it's like a boy takes over the other ones. Even though there's 2 acute, the obtuse is biggest, takes over. It's an obtuse triangle. Now be very careful, guys. Hold up 2 fingers and wiggle them. Every triangle is always going to have 2 names. You usually name it by angles first. So it could be like acute scalene, obtuse isosceles, right scalene. It's always name it with 2 things. Okay? Could you have an obtuse isosceles? Yeah. There you go. We'll construct them later. Okay, here we go. Letter A, let's name it by angles first. This is a giveaway. What kind of triangle is it? Right. Okay, so we named it by angles. Now looking at the sides, we've got this one is congruent to this one, and that's a 45 and a 45, making those congruent. So two congruent sides, what kind of triangle? There you go. Name it two things, right? Isosceles. Okay, next one, start with the angle. Because 130 degrees is obtuse, right? Okay, but then what about the sides? Sweet, there's no markings. So obtuse scaling. We didn't have any hints with the angles either. We just had the 130. Let's keep going. Okay, this is a big deal. And I gave you a clue a couple weeks ago. Guys, every single triangle, add up the angles and it always equals, do you remember? Yes, every single time. It's so convenient. All three angles, add them up, they always equal 180 degrees, no matter what kind of triangle it is. Okay, remember when I said there's one kind of tricky thing in this chapter? Here's that one tricky thing, so pay attention. This is called the exterior angle theorem. So right here, will you emphasize this? Is this little one, that's our exterior angle. It's on the outside of the triangle. Well, something happens with that triangle and, with that angle and these angles. Okay, are you ready? First, look at the red, look at the purples. Are they touching each other? No, it's all about no touchy-touchy. They're not touching each other, okay? So what you do is you take that angle 1, and every single time, it's going to be that angle A plus angle B. Crazy, huh? Every single time. So let's apply that. Let's stick numbers in there. Because if this letter A was, 45 degrees, and this letter B was 50 degrees, what would angle 1 be? Yeah, add them together. Wait, what did you say? I heard 105. Perfect. 95. That's going to come up on today's assignment, so be careful with that. We'll keep practicing. So outside angle equals the two that aren't touching it added together. Okay, this next corollary to the triangle sum theorem, I'm hoping this makes sense. Because this symbol right here, what number does it stand for? 90, right? And then all of the angles added together equal what? So if you take 180, minus 90, do you agree that these two added together have to equal 90? That's what this corollary is. It's saying measure of angle A plus measure of angle B always has to be 90 degrees. Because it's the leftovers. I hope that makes sense to you. Okay, man, we are flying. Next one, okay, you know me, I don't love these fill-in proofs. So let's do it together. So, this is the exterior angle theorem. So we've got 2x plus 4. That's going to equal, do you remember what to do with that x and the 50? Yeah, add them together. So it's going to be x plus 50. Use your distributive property. Take that 2, times it by the x, and then times it by the 4 also. So that'll be 2x plus 8 equals x plus 50. Now I'm going to subtract x from both sides. So that'll be 2x plus 8 equals 50. And then let's subtract 8 from both sides. So we've got 2x equals 42. Divided by 2.
So isn't it 1x plus 8 equals 50?
Oh, and I put the 2. Thank you. So we're done. Hooray! Right here. That's 2x, right? So is it just x equals 42?
Yeah.
Thank you for watching. Okay, but pause. I'm kind of getting nervous on these ones. I'm like queen of just not writing directions and solving. Okay, go back. It says first write and solve an equation to find the value of x. But it says to find the measure of the exterior angle. So let's take that 42. Let's put it right here. So we've got 2 times 42 plus 4. Guys, what's 42 plus 4? 46 times 2? Isn't it? 42 plus 4, 46. Yeah, 92 degrees. We got it. Make sure you read your directions on that one. Okay. We just have 2 more things and we're done. Okay, number 1. Classify the triangle by its angles and by its sides. Stop. Do the angles first. What kind of triangle is it? Just looking at the angles. Perfect. It's like a dead giveaway, huh? Okay, and then looking at the sides, what do you think? Are you positive? Go back and check the angles. Okay, the angles are all different, so it has to be scaling, right? Oh, good. Another practice. Find the measure of the exterior angle shown. Okay, so we've got our 3x plus 10. Okay, shout it out. What is that going to equal?
X plus 7.
Good job, Colton. Add those two together. X plus 70. All right. Take care of the x's. Subtract them. That'll be 2x plus 10 equals 70. Subtract that 10 from both sides. Got 2x equals 60. Pretty nice. Divide by 2, divide by 2. We've got x equals 30. Yeah? Did you get that? Okay, but I bet we have to find the angle, right? It's usually the case in these problems. Take that 30, put it right there. Because what's 3 times 30? Plus 10? There we go. 100 degrees. Okay, the one tricky thing, how confident are you feeling? Thumbs up. You feeling okay with the tricky thing? Okay, thumbs down. How you feeling about the rest of the section? Thumbs up. You okay with that? Name of the angles. Okay, you are in tables for a reason. You're in tables so you can help